November 17, Paper 1H, Question 21. Show that 6 minus root 8 over root 2 minus 1 can be written in the form a plus b root 2, where a and b are integers. We begin by writing 6 minus, I may as well sort out the root 8 now. Root 8 is 2 root 2, because 8 can be written as 4 times 2, and I can pull the square root of the 4 out to give me 2 root 2. And that's over root 2 minus 1. And what I'm going to do is multiply the top and the bottom by root 2 plus 1. And that gives me the factorisation of the difference of two squares in the denominator. So now I've got some multiplication to do. It's the top of that multiplied by the top of that, and the bottom of that multiplied by the bottom of that. So top line first. 6 times root 2 is 6 root 2. Root 2 times minus 2 root 2, well, it's negative first of all. Root 2 times root 2 is 2, and then times the other 2 makes it 4, so that term is minus 4. Now plus 1 times 6 is plus 6, plus 1 times minus 2 root 2 is minus 2 root 2. The denominator of all this, as I said before, it's the difference of two squares. A minus b times a plus b is a squared minus b squared. So this becomes root 2 squared minus 1 squared. Now the numerator again, we've got 6 root 2 minus 2 root 2 is 4 root 2. And we've got minus 4 plus 6, which is plus 2. On the bottom, root 2 squared is 2, and 1 squared is 1, so that's 2 minus 1, which is just 1. So that gives us the final answer of 4 root 2 plus 2. Or in the order they've written it, a plus b root 2, I could write it as 2 plus 4 root 2.